In this lab, we observed the motion of an object moving at a constant velocity and plotted the observed position versus time graph as well as the predicted position versus time graph. As you can see from my object of choice, I used a tennis ball and rolled it along the positive x direction. I cropped the frames to represent the motion of the ball when it looked like it was going a constant velocity, which was towards the middle of the video. Some key concepts we explored in this lab were Newton's second law of motion, which states that the change in momentum equals the force multiplied by the change in time. The ball remains at a constant velocity, which is reinforced by the momentum principle, since if the force is zero, velocity final will equal velocity initial. This delves into Newton's first law as well, which states that an object in motion will remain in motion unless acted on by an unbalanced force. We also reflected these changes in the coding. So the first change I made in my code was that I found the initial velocity by using the first 2 frames of the video, and then I divided that by the change in time. So after doing that, I got 1.38 meters per second as my initial velocity. Then I used the time of the last observation, which was the last frame, for t, and I set the force net equal to 0, 0, 0, because in this case, we're assuming that there's no net force coming from the surroundings. After that, I rearranged the formula for velocity to express Newton's second law. And lastly, I stated that we start at time 0, and I made delta t the change in time we observed in the video, which was 0.033. On the left is my position versus time graph from Tracker, and on the right is the computer-generated results. Although the Tracker position graph looks like a straight line, after looking at the velocity versus time graph, we can see that the force is inconsistent due to the external forces mentioned before, such as gravity and friction. After combining the data into one graph, I found that the graphs of the observed and the predicted looked very similar, but slightly tapered to the left for the observed position versus time graph. The assumptions made about the predicted graph was that no other forces were acting on the object, and this allows it to maintain a constant velocity, which isn't consistent with the observed position versus time graph, just because there were other forces such as friction as the ball slid across the floor along with gravity. My axis orientation was in the positive x direction since I rolled the ball to the right. This reflected my position versus time data as all my values were positive. If I changed the axis orientation, the positive values would be negative instead, and it would also be reflected in my velocity since my velocity would be negative. It's not really possible to say how many pushes and pulls were added together to give that net force of 0 in the observed case, just because there's a lot more forces that act on the system. And although we're assuming that the net force is 0 because of the constant velocity or assumed constant velocity, there could be a lot of other forces that we couldn't account for. In conclusion, through the use of Tracker, it became apparent that the velocity, force, acceleration, and momentum have magnitude and direction associated with them. We were able to explore this by understanding the effect switching the axis had. This lab illustrated the concept that force is not constant in the experimental object, which was shown through the differences in the computer model and Tracker data. Lastly, we were able to use Newton's first and second laws to explain our results and differences between both graphs.